Alright, get hyped. This is the midterm stream, guys. No one's going to be watching, I bet. That's okay. Another episode of Mike Talks to Himself is okay with me, but we're going to be jamming, alright? We're going to be solving code word problems. We're going to be, talking about new music and stuff, because these streams are boring when I stop talking and there's empty noise. I want to have something fun going on. And let me start here with this news, because I usually start with cybersecurity news while I wait for people. But there's even better news today, which is that the Fallout, well, not today, it was a few days ago, that the Fallout Magic the Gathering set is now out. And these look pretty cool. What's the deck list for Science? Because I kind of want to look at that one. Excuse me. What do you got for me? So what's the commander they got? Whenever you cast an artifact spell, you get energy. Pay energy. Target creature gets +1 and gains trample and haste till end of turn. Pay 3 energy, draw a card. Pay 5 energy. Turn target artifact from graveyard to the battlefield tap. Wow. Okay, so this is... My friend who plays artifacts is going to be super happy with this one. So whenever you cast an artifact, you'll get energy, and then you can do shit with those. Well, not only can you draw artifacts, but you can get shit back from the grave. It's crazy. Crazy shit. How would we implement this in a Python program? Oops. How would we do that, right? Just gonna make shit up, guys. I don't know what I'm doing. Just gonna make shit up. So, what is this person? Dr. Madison Lee. Vim Madison Lee. So basically, if an artifact spell is cast. So let's make like a simple text version of the program, right? Let's ask the user for a spell. If it's an artifact, or sorry, ask them for the kind of spell they're going to cast, which is going to be an artifact spell or something else, instant sorcery, whatever. If it's artifact spell, we will add a counter to it. And then we will have something to check our counters with, huh? Let's go ahead and do something like that. So, first off, we got to ask the user for a spell. The spell we're casting. Oh, I got to make this bigger. What am I doing? This is going out to the world. I got to be my best here. Boom, 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 boom. And get some coffee. Okay. So, we're going to ask the user for a spell first. So, we're going to ask the user for a spell. Let's just call it spell, and we'll have an input here. What spell do you cast? Space after. Right, if you've never seen Python before, this thing on the left over here is called a variable. This is going to be a location in memory that we get to name. You can make as many locations in memory as you like. In this case, I called the location spell. This input over here is going to ask the user for input from their keyword. It's going to ask them this question here. So it's a little confusing sometimes for some people that there's an input to the input function. But this little one is going to be printed to the screen to ask the user a question. And the input function will then take every character they type until they hit enter. Okay, so the spell is now entered. So we need to check if the spell is an artifact spell. We want to add a counter to it. So if spell equals an artifact spell, or okay, let's solve that in a second. Artifact spell. What does she do? She gets an energy counter. Okay, so we're going to need a variable, another place in memory to store our energy counters. So we'll go ahead and call that energy counters. And of course, you'll start with 0 energy counters. So if the spell is an artifact spell, we just want to increment that energy counter, right? Plus equals 1. And then we might say Dr. Madison Lee as, comma, the variable name, which will be energy counters. Say energy counters. Okay, for anybody who maybe has never seen Python before, Hopefully you have if you're watching the stream, because we have a midterm coming up. But if you haven't seen Python before, this little print function allows us to print stuff to the screen. So here we're just going to report back the information that we have, right? So we're just saying Dr. Madison Lee has, in the middle of the sentence, we're going to put this, and then the sentence will continue here and there, right? Let's test that program so far. Python Madison Lee. Right, so if I cast an artifact spell, so let's say I casted an instant spell, right, she has 0 energy counters on her, right? We didn't add to it. So again, going like this, like if you've never seen Python before, this little if statement says, if the spell is an artifact spell, right, if what I entered is an artifact spell, then we're going to add 1 to the energy counters. Otherwise, nothing's going to happen, right? So if that's not true, this line never happens here, this tabbed in line. Nothing that's tabbed in is going to happen if this condition is not true. So if I make that condition true by saying artifact spell, she has 1 energy counter now. Pretty cool. For those of you who are new, you might notice that if you change the casing here, Python will yell at you, right? It says she still has 0 spells, even though I cast my artifact spell very loudly. You'd think that the loudness would help, but no, it doesn't help here. So how can we fix this? Well, we could use string functions for this, guys, right? So we learned about string functions not too long ago in this class. But for those who forget, you can always just Google string functions, Python. Sometimes they're called methods. They mean the same thing. Well, they have slightly different meanings, but we'll get back more into that when we talk about classes. For these purposes, we are going to call them functions. I guess it makes sense to call them methods, though, right? Because functions are more like print and input, right? Those look like functions. These guys look a little different. These happen on a certain string. So for this one, the upper casing is kind of giving us a trick here, right? So lowercase does not equal uppercase. So it might be nice to kind of lower or upper our input to make sure it matches this word. In this case, I probably want to lower it, right? Because these are all lowercase characters. So that's got to match. So let's take a look at how the upper function works. In the school, before I go on, this little resource is called W3 Schools. All right, so they have tons of great, kind of good breakdowns of the documentation if you find the documentation a little too intimidating. All right, so the way this works is we have a string over here, which is stored in a variable. In this case, they call it txt. In my case, it's called spell. And they just do dot upper on it, right? So notice the syntax here. You do dot to access the function, right? So this little dot gives you access to it. Function name, and then you always have parentheses, right? Functions always have parentheses, no matter what. So even if there's no input to them. So if we wanted to make sure that even if we made a mistake, right? If we did capital letters or whatever in there, we could lower our input to make sure that it's always lowercase. It's going to look something like this. Python, Madison Lee. Right, so now when I do like something like artifact spell, even if I really screw it up like that, it's going to still count it, right? Because what happens is it lowers that string first. It makes it lowercase, and then it checks it against the lowercase version. All right, so far so good. We learned a little bit about error checking with that example. Let's make it a little more realistic, right? We want to be able to cast spells until we run out of life, pretty much. So how might we represent that in Python? We're not going to go super crazy with implementation here, right? I could go all night with this, but I'm just having fun with this right now. So let's make this code run, right? We want to repeat all this stuff, or not all this stuff, hold on. She starts with 0 energy counters no matter what. She only adds energy counters when we start casting spells, right? So we ask for a spell. If the spell's an artifact spell, we're going to add 1 to it, and then we'll report on how many energy counters we have left. But in the game of Magic the Gathering, you can cast, lots of spells in a turn. Let's say, you know what? I got an idea. Right? How about we make it for 1 turn, right? So this will be a game for 1 turn. So we'll be able to cast spells as long as we have open mana. Mana is kind of like energy in Magic. That's what allows you to cast spells. So we might start with a mana value of 0, right? We wouldn't start there. That's stupid. You'd probably want to ask the user this, right? This will depend on the scenario. Right? We're going to want to ask how much mana do we have? How much open mana mana for this turn. Right, and we'll just assume that the user will put an integer here. We can do checking later, but for now, let's just assume that's going to be an integer. Right, so what we want to do is, while there's still mana left, right, so while mana is not greater than 0, or it doesn't hit 0, we want to repeat all this code. Right, there's a fortunately there's a cool little conditional thing that we learned about. Okay, little not conditional thing, a statement, right? That's what they're called, a statement that will help us do this stuff. And is a conditional statement called the while loop, right? So we can say while our mana is greater than 0, right? We can still cast spells. So we'll go ahead and cast spells. And how about at the very end, we'll see how many energy counters we have, right? So after we're done casting like spell 1, 2, 3, and 4, whatever, then we will print out how many energy counters she has. And how's that going to look? So there's actually a mistake in this code. I'm going to run it first, though, just so we can see how it works. So we say, let's say we have 7 open mana for this turn. And what spell do we cast? Let's say we cast an instant first. That's not an artifact spell. Then we have another artifact spell. I'll go ahead and copy that to make this a little quicker. So we'll cast 2 more artifact spells. The 4th one, why not? We'll cast another instant. We'll cast a sorcery. And wow, I'm having a long turn here. So I have 1, 2, 3, 4, 5, 6, 7 spells I already cast. That's seems like we're running out of mana, but I'm still getting spells, right? So this isn't really a realistic one, is it? Yep, nothing happens, right? So this loop is actually infinite. Let's go ahead and figure out why. So this loop is infinite because mana, the value of mana is never going to change in this loop, right? I add 1 to energy counters, but I never subtract or add anything to mana. In this case, let's go ahead and just say, let's assume each spell's 1 mana. That's obviously not realistic, but let's just say it is for the actually, you know what? Let's ask the user for it, right? Let's ask the user for the cost. Right, so spell cost. I'm bad at Vim, guys. Bad at Vim. I have caps lock key on. We're gonna do spell cost. Is what does the spell cost? And we'll also assume that's going to be an integer. Space. Space. And we'll go put an int around it, and we don't need that lower anymore, right? That was only for that first input to make sure it's lowercase. Right? And then we'll subtract that much from mana. So we'll do mana equals mana minus the spell cost. Right? If you've never done Python before, it's okay to reference a variable by itself. It's going to take, what happens is the right-hand side happens first sequentially. So first it's going to calculate this, and then it's going to store the value back in mana. Right? Now you're going to see that we can actually cast some spells. So let's go ahead and say, how much mana this turn? Let's go with 5. I'll cast an instant. Let's say that's 1. We'll go ahead with an artifact spell. Artifact spell. Say it costs 3. So now we're at 1 mana left, so we have sorcery. We only have 1, so I'll say it's 1. Right, she has 1 energy counter because we have 1 artifact spell. I'm going to make this simpler. Instead of writing artifact spell every time, I'm going to make it just artifact. All right, that was way farther than I thought I could take this example, but I can think of like 15 other ways to improve this code. Let's stop there though. Right, that was just kind of kind of an exercise to wait to see if anyone shows up. It doesn't look like anyone is, so let's just have some more fun here. So what I wanted to do on stream today, well, first I want to add some music because these streams are boring with me just when I stop talking, which is often. So I'm just gonna pick some random shit, I think, for this stream, whatever weird stuff that I found recently, especially like independent artists that I think are cool, I'll try to play on this channel. And just I like loud music. Most people aren't going to like it, but that's tough. I think it's rad, and I'll keep it low. You know, it shouldn't be distracting, but I'm gonna just geek out about this stuff. So I found this band called Bilmuri recently, which is not the actor's name. I tried to search Bill, like literally Bill Murray Band, Bill Murray Band, and I tried to find them that way. I still found them, but like that's not how they spell their name. I guess it's deliberate because they don't want people to. They're kind of like a big meme, these guys, and I think that's awesome. Heard him on like the punk rock MBA channel. He mentioned it. I'm way behind on music, so these guys have been around forever. But I just found out about them last week because I don't pay attention, I guess. But these guys are hilarious. I mean, you can see just from the profile pic and the description that they're like what their vibe is, I guess. But like, what let me explain my philosophy first. So like, what I'm trying to do lately is try to listen to stuff I don't really like or didn't used to like. So like for example, I never listened to like SoundCloud rap a lot until recently. Because all I knew was Gucci Gang at the time, like back when it was relevant. That's all I knew. But now when I look back on it a few years ago, I realized there was lots of cool stuff with like Triple X and Lil Peep and all those guys had really awesome stuff. That I kind of missed out on because I'm just, you know, I just kind of say like, oh, I thought I didn't like that whole thing because one song, which is kind of stupid, right? There's something in there, I think, for everybody, right? So country's kind of something I historically don't like, and these guys kind of like mix it up with like post-hardcore sound, kind of like I don't know if you know, I mean, to most people it's just going to sound like death metal, I think, right? So it's death metal and like country pop, and it's hilarious. And it's also really just good. It just sounds good. And the lyrics are apparently pretty deep. I haven't read a lot of them, but I saw him in interviews talk about some of the lyrics and like how he kind of like weaves in like kind of deep stories in there. So I have to look out for that next time. But I'm just gonna stop talking and just put this on in the background, I think. But first, I want to just play the song that kind of got me into these guys. This song is just really freaking cool. This was the first thing I found when I searched their name. And let me just make sure it's not too loud. Please pause YouTube. Okay, there we go. Oh, good. It doesn't come through my speaker, does it? Oh, I know what it is. Oh no, I don't know what it is. Firefox audio stream. Why is this not going to my... Oh, it is. I just have to wait for the song to start. Okay, a little too loud for the stream. But yeah, right there, you can kind of see they're all over the place. I think that's... I love music that's chaotic and all over the place like this. I think it's... helps me grade your papers, let's just say that. Not your papers, your code. For the digital forensics students, it helps me grade your papers. Hopefully I don't get banned for this. I think you're allowed to do this as long as you talk over the video and like comment on it. This one's less country. This kind of more just a straight pop song. Pop like hardcore, metalcore song. Was this released 7 years ago? Yeah, they're way different now. They got really into country and their newer stuff, it sounds like. This guy here, he's apparently the lead singer of Attack Attack, which is another band I found out through Punk Rock MBA, because again, I don't pay attention to stuff that was going on while I was growing up, because I'm a loser, or whatever. But yeah, Attack Attack was kind of big back in the day for kind of being a deliberately kind of weird act. Like they did like kind of heavy stuff like this, but with like pop electronica stuff. And they're kind of known for their video where they... called Crabcore. If you guys ever watch Nick Nocturnal, he talks a lot about this. All right, that this was their guitarist in that video. He's like a crab. So like, apparently this was a trend to just do Crabcore. But yeah, that was awesome. I think these are a great band. And I'm just gonna put them on the background while I do more code, because it's the week before the midterm, and I guess I'm going to be practicing alone. Let me just pick a random. Oh, you know what? No, I wanted to listen through their album. Their most recent album was called Goblin Hours, I think. Yeah, here we go. All right, that should be a good amount of time, about 30 minutes. So once this is over, we'll probably call it a stream unless something shows up. Okay, so what do I want to actually do in terms of like learning today? All right, so I found this new site. Well, I didn't find it recently. I found it when I was kind of going through Code Academy and Code Signal alternatives, because sadly those websites have been completely gimped, and it sucks because I literally learned how to code from Code Academy, and now half the courses that I used to do that are now paywalled. So like I recommend people like I saw, I started Code Academy, and then they go there and they get a bad experience, and it kind of sucks. There's this other website called, it used to be called Code Fights. It's now called Code Signal. Until recently, this was a great site. I don't know what happened to it. Honestly, just as recently as last week, like even though it's kind of geared obviously towards like interviews and stuff, now it's just all course stuff. So now this is like a Code Academy replacement. So now I'm confused. Should I recommend this as the Code Academy replacement? Is this too advanced? It's annoying because like they had so many great examples. I literally used to like program like a half-hour a day at my old job that I hated. And I'd get so bored that I'd start programming. This site was like the best for me, and they replaced it with something that I do not care about. I mean, it's great for other people. I guess it makes them money. So do what sells. But it kind of sucks that all those examples are now just gone. So in its place, it seems that Code Wars has become the more popular one. I have not messed around with this one much, so we're going to learn it together, pretty much. So we're going to learn how to kind of teach ourselves code through Code Wars, which I think is really important if you're a programming student, because the one thing I can't really teach as a professor is how to teach yourself, which is so critical, because like, I can show you the basics, like if statements, for loops, I can show you like what errors could happen and things like that, but at the end of the day, if you don't go out and challenge yourself and find more programs to do, you're not going to really program anything real, right? Because like I can't teach you, for example, how to program an AI, because I don't know how to do that, right? Like all I know really is web stuff. Like, so I could show you the request module. Like I could go to requests, Python requests. So like I can teach you particular modules in Python, right? Like that's something, I guess, but like it's if you know how to code already, and if you know the basic idea behind a module, you can learn how to make a module for yourself, right? So it's really important that you start developing early the habit of just kind of taking on challenges that you don't know how to do. Like just say like, how do I program a video game in Python? Like that's a pretty complicated project, but you could learn a lot just by just going through somebody's tutorial or somebody's old code on it even. So like but yeah, rant over on that. So yeah, point is, you gotta practice more. So Code Wars is gonna help us practice. So I'm gonna stick with easy problems, easy Python problems. I think I chose JS because I wanted to learn JS. So let me just select Python here. We're gonna sort by. Let's go by easiest. All right, keep it easy. Difficulty. Oh, well, I'm already starting by difficulty. Okay. All right. Let me just pick this. I like this one. Flick switch. That sounds like a good one. Let's see what this is all about. Okay, this is going to be lists, but that's okay. We can learn something new, right? Don't let a new concept kind of scare us. So create a function that will always returns true or true for every item in a given list. However, if an element is the word flick, switch it to always returning the opposite Boolean value. So they give you some examples. If they give you the list with Code Wars, flick, Code Wars, true, false, false, false. As soon as you flick, the rest are false. Okay, this isn't so bad of a problem. So how do you submit solutions to this thing? Do I just have to do this like myself? Solutions. How do I check my solution? Oh, do I have to hit this? I think this is it. Let me try this one. It's a Python. Yeah, okay. Okay, so they do start you off. Kind of trying to, yeah. All right, well, let's read this. Let's not go, oh, yeah. This button will submit your code against the full set of tests. The test button will test your solution. If you care about production quality code. Oh, interesting. Okay, that's cool. Let me read that out loud instead of my head. This button will test your solution. If you care about using TDD, I don't know what TDD is, but whatever. Production quality code. Most like to try to write progression. Well, write code golf or create clever solutions, but most try to write production quality code. After you completed the test cases, you're given an opportunity to clean up code so it's code review ready. That's interesting. That's really interesting because basically they're giving you a chance to kind of write like you would as a professional, right? A chance to kind of almost like an interview question. That's kind of cool. Oh, they even let me have a Vim mode. I love it. I love it. I love the site already. It's so good. All right. So we are going to. All right. So they give us a flick switch which has this list. Okay. So if you guys you know, I know we haven't worked on a list yet, but it's really simple. A list is basically similar to a string in that instead of having a list of characters, you can have a list of whatever you want. So you can have like a list of numbers, like 1, 2, 3, for example. You can have a list with 1, 2, A. Doesn't matter. It could be any data type you want. The way we loop through lists, though, is exactly the same way we loop through strings, which is to say, for basically the element in the list. So I'll call it. What should I call it? Item, right? The item in the list. So for item in list. All right, and what this syntax means, all right, it's not list, it's LST. Just readjust here. Okay. So for item in list, what this syntax means is each item in the list is going to be, we're going to go through each item one by one. So first item will be Code Wars. Then item will be Flick, then item will be Code, and then the item will be Wars. And then the loop will end, right? So it's going to go through each item in the list where item is storing that item temporarily. Okay, so for each item on the list, we basically have to test if it's equal to the word Flick. And if it is, we need to... What do we want to do? Return a blue... Flick must be always given a location. For every item in a given list, to always returning the opposite. Weird. Hold on. What are they asking for? Are they asking me to return a list? Okay. Hopefully you'll learn something how I read instructions too, because even that can be tricky, right? So it's saying create a function that always returns true for every item in a given list. That's already a weird statement. What are you saying there? Create a function that always returns true for every item. It can't return for every item. That doesn't make any sense. You want it to return... I think what he wants is a list item, because this is what he's showing, right? So it looks like he wants a list that has true, false, 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 whatever the value is. Okay. So our basic goal then, let's write it out in comments first, right, is if item is Flick, store false, until it's flicked again, I guess, until, actually no, store you want to switch it, right? Okay, so I think this is going to be simple if we make a state for the switch, all right? So before we continue with the loop, let's say our switch is going to start with on, right? It's going to start at true. So switch equals true. So if the item is Flick, you want to flip switch to the opposite value. So when it's true, you want it to be false. When it's false, you want it to be true. So you're notting it, right? So the not operator allows us to flip a condition. So if item is flick, store false, store, not store false. We want to change the switch, right? Change the switch. And then what we want to do is store the switch in the list, in a new list to return, presumably. Okay. So now we have our plan here. So if the item is flick, make the switch the opposite. Flick the switch, change the switch. However we're going to do that, we'll go through that. And then we're going to store the value that is in the switch. That's actually a little easier, right? Storing a value is just what we did before. If you saw them earlier in the stream, right? We're just going to put it in a variable. So store the switch. So we basically just want to say, oh wait, no, we want to store in a list. Okay, so we got to learn a little bit about lists first. Okay. All right, so quick intro to lists for people who don't know. So we're gonna make a new list here that will have the new state of the switch. We'll just call it new list. Keep it simple. All right, I'm going to start with an empty list here. Notice the square brackets, right? Just like how we had for the string to denote the position, lists are denoted with square brackets because they also deal with positions, right? That's the whole point of them, is that they hold items at certain positions. This fucking album's all over the place and it's awesome. What is going on? I love this band. Anyway, so where was I? Okay, yeah, so we have an empty list, right? And we want to add the value of the switch to the list. So you would think that you could just like add it with a plus sign, right? You would think you could do new list plus the value, or plus equals the value, right? Like adding it into it. But this has two problems. One is the plus only allows you to add two lists together, right? So if you have list 1, 2, 3 and list 4, 5, 6, if you add them together, you get 1, 2, 3, 4, 5, 6. Why am I saying it? I should just fucking do it, right? Right, so if I have list 1, which is 1, 2, and 3, and I have list 2, which is 4, 5, and 6, and I do L plus A, I'm going to get the list together, right? Them added together. But if I do something like L plus true, that's going to give me a type error, right? You can only concatenate lists together. You can't add numbers or strings or whatever the hell you want to, right? It has to be a list. So if you want to add something to the list, you have to use something called list methods. And these are conveniently also on W3 schools. So list functions. Oh, no, we get it right there. Right, what's that first one saying, right? This one adds an element to the list. So if we wanted to add something, we're going to want to do something like this. And you have the items you might expect. Like you can remove things from the list, you can insert them. We'll get super into this when we get to lists in the next few weeks. But, oh, damn. Bless me. Okay, if we want to append to this list, similar to how we use a string function, we're going to use a dot to access the function. We have the name of the function, and then we're going to have the input to the function, right? The thing that we want to add on to the list. So here they have a list of apple, banana, and cherry. They're going to add on an orange to it, right? Just like magic, it adds it into the list. Okay, so back to the problem at hand. That's the wrong window. Let's try this one. Okay. So we're going to use that same syntax of appending whatever the value of the switch is, whether we flicked it or not. We're going to append it to the list. Okay. Okay, so far so good. Can I run this and like have it run? I'm just curious what'll happen. Because it's always good to kind of test our code while it's going. Let's go ahead and test it so far. Okay, none should equal, oh, right. So we're getting none here, because we're not returning a list, right? So at the very end here, instead of printing out this list, what we're going to do, which is normally what we do in a lot of programs we've done, we're going to return the new list. Oh, sac solo. Fuck yes. Test. Okay. Notice some of the tests started passing, right? So those are the cases where it's an empty list, right? Where I guess they give you an empty list as an input. I don't know. Whatever's going on there. We're returning an empty list here. But take a look at the list that I'm getting out, right? So I'm getting true, 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 true. These are the outputs I'm getting out over here. It's saying this should equal the other one. And so I'm always getting true, right? And that should be expected because look at how our code works so far, right? Switch is true, the new list is empty, and we're just going to add the switch for as many items as there are on the list. Since there's 4 items on the list, it's going to append true 4 times in this case. And same with all the other examples, right? So now we actually have to implement the flick functionality, right? We have to flick the switch. So how are we going to do that? Well, we kind of have a clue where they're comment here, right? If the item is flick, we're going to change the switch. So that kind of implies that we're going to use some kind of if statement here, right? We're going to check something. So if the item equals flick, right? We use double equals for comparison, 1 equals for assignment. So if the item is flick, we're going to make the switch the opposite of what it is. Now, this might be kind of cool for those of you who may not have seen it before, or might not be expected. I don't know what I'm saying. Might not be expected for those who haven't seen it before, but you could do something like this for this problem. Not switch. What does this mean, this not thing? So not is like taking, it's kind of just the opposite of, it just takes the opposite of your Boolean. It's kind of like negation, right? So if I have 10, for example, I have 10 times -1, that's going to negate, -1 negates my 10, right? So if I have something like true, if I do something like not true, that's going to flip the condition for me. Okay, so this not operator is kind of negating that condition. It's doing the opposite of whatever the condition was before. So back here. Right, so this little switch equals not switch here. Let me just make sure you can actually read all this code before I continue. So I just realized the code's a little small. Oh well, I couldn't really read it. Oh well, I'm still learning. So if the switch is flicked, right, if the item is flicked, we're going to flick the switch. And then we're going to store it. All right, so what is this going to happen? What's going to happen? Let's take a look at our examples. All right, let's run through it. So first item is Code Wars. So Code Wars equals flick. That's not true, right? So we don't do anything. We store true. Next word is flick. Flick does equal flick, right? So switch is going to be equal to not true. It was originally true. Now it's going to be false. So now we're going to store false. All right, so for item and list, next one's code. Code does not equal flick. We don't have to flip the switch. The switch is still false, so we append false. And you can take a guess what's going to happen on that last one. Okay, and this should basically allow us to flick back and forth. So if they put flick again, right, if this one was flick, the rest should be storing true. Let's go ahead and test our code. See if we got it. Okay, we got the basic test code. Let's go ahead and attempt this. Fix test. There we go. All right, we did it. All right. I like this site. This site's pretty cool. Let's try another one, huh? We still have time. These guys are awesome. I look over here and I have no idea what's going on. Okay. I'm sorry. I'm speechless at how cool their music is. Let's go to easiest again. Let's go to Python. Let's see if we can get a string one. Strings. letter's best friend. Okay, I like the sound of that one. Let's check that out. It says 1 issue reported, but I'm sure it'll be okay. Oh, I have to right-click the thing. So, yeah, this thing. Given a string, return if a given letter always appears. Given a string, return if a given letter always appears immediately before another given letter. What does that mean? Worked example. HE headed to the store. HE true. Oh, okay, so he's saying all occurrences. So all occurrences of H and E always appear before. So, in other words, all the occurrences of H are these, and all of them have an E after it. Oh, okay, I get it. Okay, so what he's doing is he's finding everything that starts with one letter, and then checking that they are preceded by a letter after. Gotcha. Okay. All sentences will be given lowercase. Okay, that helps a little bit. Okay, that's interesting. This one's kind of hard. Let me think about this one. So the goal here, we can't necessarily assume it's going to be words, right? So it could just be like random characters. Like it could be something like this, right? And if it's HE and then HE and all that, right? So it could be something like that. I guess what you could do, you can use find. Let's go over the find function, because that's kind of where I'm thinking of going with this. I'm not sure if it's the right approach, but it feels like that's what you have to do here. Right, so this find function is going to find the first occurrence of the word, specifically on the left side, right? So let me show you. Like if I have the word welcome a second time here, which is kind of the goal, right? We're trying to find multiple counts of this word. Right, it's only going to give you the position of the first word, right, which is 7 here. So we're going to have to kind of find them one at a time, right? So I'm thinking find the first occurrence of this letter, check the one after it. If it is, cut that part of the word out, so cut out everything up to that position, and then search again, kinda. I think that's going to be the way. All right, so let me write down this plan. So text is in txt, A is the first letter, B is the second letter. Does it matter the word? Second E. I see. So in this is a weird example, right? So here he's saying if it's E after E, right, that you want to make it so the first E is here. So the first occurrence of the E is here, and the next character is E. But then if you find this and go to the next character, you won't find a second character, right? So it should be false. Okay. All right, so I definitely know. So what's the goal here, right? We have to definitely find the position of A, right? So find position of A. Then check if B comes after A, right, is in the next position. If it doesn't, return false, right? Because it doesn't matter what the rest of them are. If you found one, that's it. It doesn't do it, right? So even one condition will return false. If it does, cut the word and do it again. Oh, this is a recursive problem. Okay, we're not going to talk about recursion in intro. Let me try to do a non-recursive solution before I do a recursive solution, though. All right, but this is the basic plan, right? Find position of A, check if B comes after A. If it doesn't, return false. If it does, cut the word, and and do it again. I guess as long as there are still letters in the word, right? Well, let's get the basic process first. All right, so find position of A. That's easy. Position equals text dot find A. How do I know that? Find function, right? Dot to access the function. The name of the function is find, and the word we're finding is welcome. Is this over? No, it's not. Cool. Okay, check if B comes after A. Okay, that is also easy. All right, so now that we have the position of A, we need to check if the next position is equal to B. Next position in txt, right? So the first position of A is going to be given in this position, right? So txt at position is going to be whatever character A is. So like, for example, H. Like if A was the letter H, it's going to go to the first position where H is found. So I want to check the one after that, so +1, and I want to check if that equals the letter, whatever's in B, right? So the letter E. So if text position is B, okay, so what do we want to do? If it comes after B, actually, no, okay, so this first condition, right? If it doesn't, return false. So let's say if it doesn't equal B, return false. Else, we want to cut the word and do this whole process again. So let's figure out cutting the word. So basically we'll want to cut out everything up to everything from the current position and after, right? So let me work this out, right? So let's say we have the word is a hello. And let's say we want to get the position of the first L, which is 2. Right, so word at 2 is going to be L. Word up to 2 is going to be HE, so we're not including the L. That's important, right? It always goes to the word not including that one. But if we go from the L, it's going to include all of it, right? So it'll include both L's here. So if we wanted to do immediately following that, we have to do 2 + 1. Okay, so in this one, the new word, right? So txt is now going to be equal to itself from the position +1 to the end of the word. And then we're going to do this whole thing again. Now, I strongly want to do recursion here just because it's going to look so beautiful and it's going to be so easy. Oh, I forgot to return false, right? Return false here. Oh, hello. Someone's here. Let me lower this a little bit. The midterm example you mentioned in class. Well, first off, hello, Anisha. Thanks for your questions. She wanted to ask about how much the weight the midterm holds for your final grade. Okay, so this answer we can go ahead and get from Professor Vitale, actually. So let me go to her Moodle course. Oh, that's my Moodle course. Whoops. Try that again. This one. Course syllabus. Okay. We will go ahead and zoom on this. Okay, so as you can see, the lab assignments are the bulk of your grade, right? So if you're getting an A in lab, that's 50% of your grade right there. So if you're getting an A in lab, you're doing pretty good. The quizzes are only going to count for 10%, and that's overall, right? So that's like all the quizzes combined, that'll be 10% of the grade. The midterm is 15%. The final is going to be 20%, and participation is 5%. So, in other words, if you're showing up to lab and you're trying on all the assignments, you got 55% of your grade as an A already, right? The midterm doesn't count for all that much. And the second question was, where could I find the midterm example? Well, let me leave this up for a second, just in case you have any questions about it. But let me start answering that question. This melody's so good. What a stupid fucking song, though. Wow. Okay, so that is the midterm grade. So on to the question about the midterm example. So it is not actually up yet. Well, I'm not sure which example you mean. Oh yeah, no problem, Nisha. Yeah, thanks for watching and thanks for the question. So on to your question about the midterm itself. So I think the one I'm referring to was last semester's midterm. I think that's the one you're referring to. I have not made that one visible yet. The reason why is I wanted to give people a chance to kind of quiz themselves if they wanted to. So like you could kind of do like a mock midterm on Wednesday if you wanted to. You don't have to do that. You know, you could go through it slowly. This one is kind of hard. I'm not gonna lie. That's part of the reason I made this midterm a little bit easier, but it does have a lot in common with the problem that we're gonna have for the midterm. I can give you a sneak peek if you want. Right, so the goal of this program is a candy counter. So last semester, the midterm came right before Halloween, so I was like, oh, I got to do a theme problem. It's just got to happen. So the goal of this problem was to allow a user to enter a number and then a word. And then based on this number, right, so everything up to the space is going to be a number, and you add that to a certain category. So for example, if you had 5 chocolates, you would add 5 to your chocolate bag. And then at the end, you print out a report. I'll give you the full detail. Oh, a bit confused. So there'll be 2 midterms for lab and lecture? No. So, oh, okay. Yeah, sorry. We're having 2 different conversations, sort of. So, yeah. So this one's not going to be visible yet. I'm going to make this one visible tomorrow. But if you want a sneak preview, that's it. That's what we'll work on tomorrow. All right, and you get the full details there. But that one is a little bit harder than what it'll be. But if you can do that one, you know, you're going to be all set for the midterm, really. To your other question, are there 2 midterms for lab and lecture? Kind of yes, kind of no. They're not separate midterms, right? So they're 2 different parts. So in other words, the midterm is going to have 50 points of a lecture part, which is going to be like a traditional test. And the other 50 points will be my lab. So like, let's say, for example, let's say that let's say on the test you didn't do so good. Let's say on the test you got like a 75. No, not 75. It's going to be out of 50, right? So let's say you got like a 35 out of 50. And let's say for the midterm, you got, let's say you did better on the midterm, right? You got a 40 out of 50. Right, we're going to add these 2 grades together. So 40 plus 35, it would give you 75 out of 100. Another example, right, if you got 50 out of 50, right, that would be an 85. 50 plus 35 would be 85 out of 100. Or the other way, right? So if you didn't do so good on the lab, right, you got 30 out of 50. And say you did really great on the test, 50 out of 50, that's going to be an 80 for overall. Okay, so that's it in a nutshell. Yeah, that's all it is for grading. If you have any other questions, let me know. We could do a problem or 2, or if that was it, that's totally cool. And let me get back to the problem I was doing. Oh, crap! I closed the music. Oh well. Yep, no problem. Thanks for the question. Hope that was helpful. So what I'm doing here is I'm doing some harder problems right now. I'm hoping maybe I'll cut out some of these for videos for you guys so you can kind of see how to solve these. But yeah, I was just about to wrap this one up. So this one I got to return false here. Find the position of A. Right, do it again. So the do it again part, I wanted to ask for some help to get started on one of the bonus labs. Code check one. Oh, sure. Yeah, absolutely. Take a look at that one. Okay, display if a string the user enters contains the word COE at the beginning, at the end. We'll count any character in place of underscore. So it's kind of like a fuzzy match sort of thing. So the first 2 letters have to be CO, and then the 4th letter has to be E. or it has to end with, or both. So, lacking a specific question, let me give you a kind of example of what I actually mean, because I think even wrapping around what exactly I'm asking for is a little tricky here. I'm going to go ahead and make a new file. All this code. Wait, actually, let me go to my work directory. Code checker. Okay. So let's take like this example phrase, just like to kind of get started. Let's say the phrase is this one. Right, we're going to want to replace this with an input later, but let's just take that as an example. So if I were doing this like by hand, right, not using Python at all, how would I check if this is true? I would kind of look at the last 4 characters, right, in this case. So I'm looking at the last 4 to see if these two are CO, and I'm checking if the last character is E. And for the beginning, you'd want to do vice versa, but let's start with the one at the end, right? Yeah, actually, no, let's start with the one at the beginning, because I think that's easier. Let me pick, let's start, actually, this one's perfect, because it has to match both. Go with this one. Right, so this one starts with both code, and it also ends with something that's like code, right? So this one should say starts with code and ends with code, or ends with COE, rather. So for the beginning part, we have to check if these first 2 letters are CO, and if this letter is E. Okay. So this is all about indexing, right? So I always kind of, well, especially if you're, well, I don't always do this, but sometimes I do this, especially if I'm working with kind of particularly weird problem, is I always kind of like put positions. Sometimes I do it in my head, sometimes I write it out. But all of these guys have a position starting from 0, right? And that's going to help us slice out the phrases. So if our goal is to slice out the first 2 letters, how are we going to do that? So let's just try printing it first, right? So print the phrase. With these square brackets. All right, let's just do a simple example, right? So the first character, starting there, right? That's going to print the first character of that word. Python code checker, right? That's going to print the letter C here. Okay, if I want to slice the first 2, right, what position is this guy at? Right, this guy is going to be at position 1. So we want to go, you might think at first, like go to position 1, 0 to 1, but this actually doesn't work as you might expect. This one's also going to print C. So the reason why is kind of like with range, this is going to go up to that character but not include it. So we're going to have to go 1 more to get the first 2 letters. So 0 to 2. Code checker. That's going to get us CO. And that's, of course, it doesn't matter what the phrase is. So let's change the phrase to something like this. Hello. Right, this one's going to print out HE, the first 2 letters of that word. Okay. So now we got to turn this into a condition. Now that we understand what we need to slice out. Actually, I'm sorry. How do we get the E now, right? Let's think about that one. I'll give you a second to kind of think about that one. Right, how are we going to get the E? I know there's like a 10-second delay, unfortunately. What's going on with Bilmuri? Yep, that's exactly right. E is going to be 3 here, right? Because it's in position 3. All right, so we know, let me go back a little bit, right? So we know that this is the first thing we need to check, and we know that this guy is the other thing we need to check. Now let's turn this into an if statement. All right, so to check the first one, if phrase, we want to check if this is equal to the letter CO, right? So we can just say equals CO. All right, that's the first condition. So if that's true, if this and the other thing is true, we would say print starts, I'll call it code like, right? It's code like, COE. So let's just go ahead and stop there. And while I'm running this, think about what's the condition for E, right? So what condition I'm going to add on for E here. Right, so you can see that it says starts code like, COE. Right, so what's the other thing that needs to be true here? And how can I add that on? Phrase 3. Well, that is the section, right? Yeah, but what is it going to be equal to, right? So I think maybe I just asked my question a bad way, but you got the right idea, right? So you want to check if phrase 3 on, well, actually, hold on. 3 onward is what you wrote, right? So you wrote this. I thought you wrote 3 itself. So 3 onward is actually going to be something different. Let me just comment this out so print it out so you can see what it is, right? So if I print out phrase 3 to the end is how I'd read this, equals 3. Oh, I see. Yes. Okay. So not quite. So what I need to do is actually check if the letter is E, right? So let me print this out first. I think it's going to make more sense. So take a look at what that printed, right? It printed out E, XX, and all the rest of the word, right? Why did it do that? Right, go back to here. So it's going to go to position 3, this one, E, and go to the end of the word. In this case, I'm asking you to check if the first 2 letters are CO, and if the the fourth letter is E. So in this case, the fourth letter is just without those brackets, right? So you only want to use the brackets, colons, right? You only want to use those colons when you're doing a slice, if you're slicing a string up of some sort, right? That's going to print just the letter E. So in this case, the solution actually is something like this. Right, you want to see if that fourth letter is equal to E. Right, and oh, I made what did I make a syntax error on? You can see that right there, I hope. Right, I make this mistake every day. Okay, so it starts code like COE. So now let me make it input so you can actually see how it responds to different words, right? So let me go ahead and make this an input. Input word to test. So that means, so I do Python. So now if I put in a word like code, right, obviously that starts with CO, and it ends with the letter E. Well, not ends with, it starts with CO, and the fourth character is E. If I do something like Codecademy, I don't know, Codecademy, that also starts with COE, right? CO are the first 2 letters, E is the third letter. If I do something like Cope and Seethe, that's a popular one nowadays, right? That is also code-like because it starts with CO and the third letter is E. As soon as I put in something that's not like that, so something like, I don't know, CRUD checker, right? That's just gonna, well, I'm printing, I should get rid of that extra print, I'm sorry. You're probably confused why it's printing out a letter. The reason it's printing out a letter is because I forgot to take this part out. Right, so if I have something that doesn't start with code, right, CRUD check doesn't print anything. If I start with something with CO but doesn't have an E, so like I was gonna say come on, but that does have an E, right? So that's code like Python CO copy, right? Copy. That doesn't end with an E, so that one's not gonna check out, right? It starts with the CO, but it doesn't match that second condition. Okay, let me go ahead and pull up the code so far. Let me know if you have any confusion up to here. Now, let me double check the problem instructions to make sure I didn't miss anything. String of that. Okay, I think it's just the one check. Oh, and the program should not display anything if the length is smaller than... Well, that's not going to happen anyway, because if you don't have 4 characters, right, what's going to happen? Oh, actually, that'll be a fun one to test. We'll do that in a second. First, I'll wait for any extra questions. It looks like... I think you got it, but I'll move on to the next part in a second. Great. Okay. So now the other part, right? How do we check the words at the end? So this one is a little trickier. Let me go ahead and go back to the example that I had. Oops, that's not what I wanted. Where is a code? This one. Right, this one ends in and starts with. Okay. So the goal to this one is that finding the last one depends kind of on the length of the string, right? So in this example, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? It goes up to 9. But if I had a smaller word, right, we wouldn't have 9 positions. And that's going to give us an error. Actually, this program has an error as is, right? Watch what happens when I put in... Oh, yeah, I'm sorry. I should have actually put in a word. Right, so if I put in a short letter like CLE, this program is actually going to give me an error because it's trying to get the 4th character in that word, but there is no 4th character. So we have to use the function ends with somewhere here. You could, actually, right? So let's talk about ends with. How could ends with help us with this one? So, go back to the other word. Nope, that's not the other word. Copy that. So what does the ends with function do? Right, so the ends with function... Where is the ends with function? Here we go. Ends with. So ends with will tell us if it ends with a certain character, right? What is the letter that it needs to end with here, right? If we're looking for a code, it has to be the letter E. Right, so I think you can probably guess where I'm going to go with this, right? So if I wanted to use ends with, I could do something like this. If phrase dot ends with E, print ends with E. We'll keep it that simple to start. Let's see how that one works. Python code checker. Oh, sorry, let me go back to the input. I'm sorry. No, let me keep this, right? So this is our example. So we have code in front and we have cope at the end. You see the E on the end there. Okay, and you can see that it ends with the letter E. Okay, so that's great for the first part, but I think I know where you're stuck, right? So the tricky part here is going to be how are we going to get these letters, right? How are we going to get these two guys, CO? So this problem can actually only be solved with a negative index, which we haven't talked a whole lot about, but it was gone over in lecture, I think, a couple times. So the way negative indexing works is if I imagine I'm going backwards in the string, this character in the back here, this E, can actually be represented with the character -1. And then you can count backwards from here. Let me show you. It's a little weird, especially the first time you try it. So let me give you some examples. Right. Right, that's Python. Oh, you're way ahead of me. -3 to 4, exactly. Yeah, yeah. Let's talk about why. So let's say that word. Let's copy the actual thing. So let's go ahead and do this. I'm just doing it interactively, kind of. Oh, no, I'm still not doing it. Okay. Let me just do it the correct way. Right, so let's go ahead and print out what you just wrote, right? So print phrase -3 to -4. Oops, I forgot to run the program. That would help. Python code checker. Okay. Interestingly, that didn't print out anything. It should have printed out something. Did I type it wrong? I think I typed it wrong. I must have. Then print phrase -3 to -4. So I see your thinking, right? So this character here, so -2, -3. Oh, I see the error. I make this mistake all the time. So this character O is -3. This one's -4. The order matters here. So if you start from -3 and you want to go back to -4, you also have a step here, right? So remember, there's a third thing here. There's a step. So by default, it's going to be 1, where it's going to try to go from -3 and then go up to -4. That, of course, won't happen. So you have to specify that you're going backwards in this case. Let's see how this one's different. Right, that's going to get us the letter O, which is also not what we expected, but closer, right? So what happened here? So we started at -3, the letter O, and we went back to -4. So we went back by 1. We did that correctly. But there's a problem, right? If we end on this number, we're not going to include this number. So we got to go 1 less than this one. That's going to look something like this. OC, right? Going backwards. I think from there you can pretty much get the rest of the problem, right? So you got it right? That it's going to be this little guy, this guy here, that is going to go get the CO here. But the only trick here is that it's backwards, right? So think carefully about which one you're going to check. Are you going to check if it's equal to CO or OC? Right? In this case, what are we printing out here? Right, we're printing out OC. Yeah, negative indexing is really weird. I mess it up all the time because you got to remember the direction that you're going in the string. Do like a couple other examples that would help, maybe. Clear the screen. So like, let's say my was hello world. We would write a lot of the code before, so whenever I input a code, nothing prints out. Huh. Well, I don't think that happens with this program. Oh wait, I gotta make this an input again. Yeah, make this an input. Input word to test. I have a feeling if you were doing the other thing, if you did the -3 to -4, that might be the issue that you had. This one should work with a code. Put in a code, ends with E. I mean, I'd have to write on the other, I have to write out that other condition. Right, but I think you get the idea. Maybe if you send some sample code, I could take a look at it specifically. We could figure out kind of what went wrong with it. If you need somewhere to share code, you can always use the site, Python. I'll let that cook for a second. Let me put on some Bernstein. Singing this piece in choir, it's a lot of fun. Oh, it's so loud. My loop's just temporarily there for convenience of testing. Oh, you're talking about what you have on Moodle. I'm sorry, dummy. Which one are we doing? This one. No, which one are we doing? Oh, code checker, right? Oh, I see what you did. You did it the other way. Okay, that'll also work. Well, will it work? Actually, let's double check that. Python. So let's say we have the word is a code. If we do word, we'll print it. Print word -4 to -3. What happens here? C. Okay, that I think is your problem, right? So you want both letters, CO. So think, where does this one end, right? It ends not including this index. Spoil it, right? It's going to be something like this. If I get one, it's going to be that. If I go to the end of the word, it's going to be the whole thing. Just like magic. Okay, so the lesson here is when in doubt, print your slices out, right? So print out this guy, print out what this guy is, because it's not always what you think it is. It's a little tricky, especially when you're doing negative indexes, because you lose track of which way you're going. It's a mess. This music is too majestic for what we're doing right now, but I'll accept it. So go back to code. Actually, you know what? Let's just leave your code up. I like your code. Your code looks great. Okay, what else can I talk about? Well, let me more of the pre-con. What else they got here? Okay, I'm not going to go through cards while you're trying to figure out this damn problem. Let me pick up my last example. What are those cards I'm looking at? Oh, this is a game called Magic the Gathering. My friends really like this game. So what's cool about them is that they release sets that are themed based on like I guess nerd stuff, right? So like one set they had was on Lord of the Rings. Those were a lot of fun. Those cards I bought LTR MTG, which I'm sure you're familiar with Lord of the Rings. Even if you've never watched it, most people know. So with Lord of the Rings, you can play things like Frodo, you're going to play Gandalf, and you can kind of like summon them as your creatures and have them do your bidding. Um, this one's going to be the Fallout series. Um, yeah. uh, they got a lot of cool stuff. Oh, look at this Nerd Rage. Wouldn't you just love to like play that on a table? Like I'm gonna cast Nerd Rage right now. Everyone would get up and leave. What does this do? When it enters the battlefield, draw 2 cards. Enchant a creature has you have no max hand size. What? That's nuts. Whenever this creature attacks, you have 10 or more cards in hand. It gets a plus. That's also not. Oh, so it's a draw deck. So the strategy behind this card, right, is to try to draw as many cards as you can. That way you can get a creature buffed. What I like about Magic is that it kind of forces you to think a little bit. Like the conditions are really complicated sometimes, and honestly, it helps with code. So like one of the codes, the first thing I did while I was waiting for people to show up was I kind of just wrote a Magic representation of Madison Lee, the Planeswalker there, and the way she works is she gets energy counters, right? So she starts with 0. I know people, but it's not anything like Uno, so I don't get how they do. Yeah, it's a little more than Uno. Yeah, it's too much. Yeah, it's really a game you have to kind of think about a lot. I wouldn't recommend it to someone who doesn't have a lot of time and money on their hands because it's a sink for both of those. But my friends like it. We like playing it. So my disposable income goes towards this. But yeah, what's cool about it is the conditions do get really kind of complicated. You really have to kind of think through it. I feel like it kind of helps me get better at programming because like you have some cards like, let me get like a really complicated one like this one, Animate Dead. Wait, where's the card? Animate Dead. This one. Like, what the hell is this? Like, what are they thinking with all this text? It's just so much. Like, but I mean, it makes sense when you read through it. But it's a lot to take in. Oh, I'm glad you think so. Yeah, I think it's a fun little game. It does get a little annoying though, just because it's very easy to like it's a game of chance, right? So like if you don't get your cards, you're kind of just sitting there and you get killed. So like that's no fun. But when you get a good hand on both sides, that's when it gets really fun. If you want to play with like no time sink at all, I'm sorry, no energy sink at all, you can check out MTG Arena. It's like kind of like a video game version of it. That'll kind of show you the basic rules and stuff. It's not like it's kind of a time wasting game. It's not really that fun, but like no, it's fun. It's fun building the decks and going through the decks they have. Yeah, Magic the Gathering Arena, that's what I started with. One of these days I should make like a programming problem with Magic the Gathering, but I feel like half the class is gonna roll their eyes at that. Maybe someday I'll come up with one. I have to find a good enough condition card. Anything with if statements will help. Or even better, if it says for each creature do this, then I can do a for loop. Oh yeah, that'd be cool. I wonder if that should. Yeah, I guess it probably does. Yeah, okay. Oh, I got on a tangent there. Did I answer your question about code checker, did you have any other questions on slicing or any kind of any other weird problems that I could tackle for you? And I asked that knowing there's a 10-second delay. Bring back my slices. What is a code? Slice that guy up a little bit. What's annoying about this is you can't go backwards like that. Really annoying. You have to do this. Yep, so whenever it can't like go up, it's gonna give you nothing. So if you ever get like behavior like that, you kind of want to just print it out and see what you're getting. That was it, honestly. Okay, great, awesome. All right, then cool. I guess I'll just we'll call it there then, pretty much. I don't have any other students waiting, so I was gonna end the stream soon. But if that's all, we will I guess log off and we'll talk tomorrow. We'll do some more problems. I'm not going to get to the end of Bernstein, but that's okay. What else I got here? Oh my god. They have a robot dog. That's amazing. It's a little bit of it's that's left. And don't worry about that. I got plenty of time. I will make the time for Helldivers. No, no, you're not holding me at all. So don't apologize, right? The whole reason I do this is to help you guys. So never apologize for that. But yeah, I will see you tomorrow. All right. So I'll go ahead and close it up. Let me just close out all these. Yeah, I don't want to finish this. And let's go ahead and... Okay, if you're still listening, see ya. Ending the broadcast now.